All right, in this example, we're given some sequences and asked to find an explicit formula for the general term of the sequence. Now, this is another one where I think it's better for you to try this on your own before you just watch me do it. Just because the thought process is really what matters. You know, it's not always straightforward. But so if you haven't, give it a try and you can come back. But I'm going to go through this example now. So you can see kind of what the pattern is in the denominators, right? You can see definitely a pattern in the denominators. It goes 2, 4, 8, 16, 32, 64, which is obviously 2 to the n, right? So we have a pattern of 2 to the n in the denominator, right? So we could write 1 over 2 to the n, right? Now, the only other, the numerators are all 1, so that's good. But we have these alternating signs. So it's positive, negative, positive, negative, positive, negative. So we got to figure out how to get that to happen. So I'm just going to write a sub n equals that. So one way that we can get that to happen is by taking powers of -1. Right? So if we have an even power of -1, it'll be positive. If we have an odd power of -1, it'll be negative. So we just have to figure out, okay, where are we starting? We're starting at a1 is positive. So I want a1 to be positive. So I've got to take, I need an even power. Or it could be a 0 power. So there's a couple of different ways you could write this. You could write this as -1 to the n minus 1. So that would mean when n equals 1, -1 to the 0 is positive 1, right? And then so we'd have positive 1 over 2 to the 1, which would be 1/2. And then when n equals 2, you get -1 to the 1, which is -1, times 1 over 2 squared, which is 4. So that gives us the pattern. Now we could also write this as -1 to the n plus 1 if we wanted to. We just need it to be, offset, right? So if the term number is odd, then we want the power of -1 to be even, right? So that we get a positive number. All right, so that takes care of that one. Now in this one, the pattern in the numerator is fairly straightforward. The pattern in the numerator is just 1, 2, 3, 4, 5, and so on. So it seems like we've got n, right? So whatever the term number is going to be in the numerator. Now in the denominator, we've just got odd numbers, right? 3, 5, 7, 9, 11. They're advancing by 2 every time, right? So 3 plus 2 is 5, plus 2 is 7, plus 2 is 9, and so on. So now you know that we can get an even number just by taking 2 times n, right? And if we either add or subtract 1 from an even number, we get an odd number. So let's try and figure out what do we need to do to get the odd number that we want in the denominator. So if n equals 1, we want the denominator to be 3. So 2n is 2, so we want to add 1 to it, and then we get the odd number, right? And then we'll just get consecutive odd numbers in the denominator. So that takes care of example 2. And I will meet you in the next video.